Hey everybody, review for the quiz on the very last part of Unit 5, vectors, polars, and complex numbers, graphing, and calculating all three. Now pretty much everything that's on here is on the quiz. I know this seems large and there's just really a lot of the same thing kind of over and over again, but you're going to be asked to do a lot of different graphs and calculating the absolute value or the magnitude, and of course the angle or the direction of pretty much any of the three types of numbers that we have. So for this first question, it's described to you at the top. We have vector p, the tail's at 4, 8, and the head is at negative 3, 1. So if we put this in component form of p, remember this is head minus tail. So it would be negative 3 minus 4, and then of course 1 minus 8. And putting that in vector form will give you negative 7, negative 7. The absolute value is the magnitude of this vector, the length of the vector. And so this would be the square root of a squared plus b squared. Now, of course, with the sides being the same, the hypotenuse or the length of the magnitude is going to be the number radical 2. This is 7 radical 2. You can have a decimal here if you'd like. And then, of course, you're asked to draw the graph. The graph is important that you indicate which one is the head and which one is the tail by using the proper notation. The tail is the point or the part that does not have an arrow at 4, 8. And then, of course, the head is the part that does have the arrow at negative 3, 1. On the quiz, there are 17 questions, and there's pretty much one of everything. Like there's one of these, but by these I mean both. Put it in component form, find the magnitude. There's also a question like about equal vectors. So are these vectors equal? First thing you want to make sure is that they are in component form. So don't be fooled by one maybe in component form and the other isn't. Maybe one's drawn and one is written out. Please make sure you get them both in component form so that you start where this problem is starting. And these, of course, are not equal vectors. And the reason is the components are not equal. To get even more detailed, if you wanted to, they're not the same direction, right? Because they're in different quadrants, they have different angles. So all that stuff is on the quiz so far. Now you are going to also be asked to add, subtract vectors, both symbolically, which means obviously with the numbers, and then graphically. So that's what we have here. This one is s plus t. So it doesn't really say s plus t anywhere, which I think is weird, but it is definitely vector s plus vector t. The word add is there. So when you add them symbolically, the horizontal component goes with the other one. So that's 2 plus negative 5, which is negative 3. And then we have 5 plus negative 3, which is, of course, 2. Now to draw this, you take that first vector and you put that in standard position. So standard position means it starts at 0, 0. And we're going to go right 2 and up 5 from 0, 0. That's where the head is. And then you go tip to tail. So starting there, this one is vector s. So starting at that vector, from there we count to the left 5 and down 3. And that is the head of the second vector, which is vector t, and then you connect that opening with its resultant, and this is s plus t. And of course, s plus t should point at the same answer that you have here, negative 3, 2. To subtract, up to you if you want to add the opposite or if you want to actually subtract. The opposite of vector w is the opposite in all cases. So to multiply or distribute a negative 1 through both components. So now we have negative 3, 5. So we're going to take negative 1, 7 and add that to negative 3, 5. So the component form is going to be negative 4, 12. When you graph it, I would suggest using the additive inverse to use that opposite vector, if you want to call it that. So we're going to start, this grid is not as good, we're going to start with vector v in standard position, and vector v is left 1 and up 7. I'm hoping the red shows up okay. That's vector v. Then from there, we're going to count left 3 and up 5. And you connect that. Now this barely looks like a triangle, but it does, it's kind of a skinny little triangle here. We would connect it. And so this is vector opposite of vector W, and then this result is vector V minus vector W. You will have one where you have to do the symbols and one where you have to do the graph. I don't know if it's adding or subtracting, but I can tell you that it's not this third kind where it's the scalar. And scalar, of course, is just to distribute or to multiply by that scalar out in front. So to take 3 times vector u, distribute that 3, we would get negative 6, 9. To draw the graph, you would draw vector u 3 times tip to tail. This will turn into a line with basically like 3 segments to it. So here's vector u, count negative 2, up 3 again. Here's another vector u, and then do that the 3rd time. Oh, it takes us right to the corner. And so there's vector u for the 3rd time. Sorry, I lost page 2. For 6 and 7, it's the same question, magnitude and direction, but just different starting points. In order to do magnitude and direction, you have to have components. So you want it to look like problem number 7. There will be one of these on the quiz. I just don't know. I don't know which way it'll start, either with the picture or with the component form. So from the picture, we need to do head minus tail. So I'm going to write it down that way. The head being, of course, where the arrow is. This is the point 5, negative 3. Be careful with this, and that, you know, if you read the graph wrong, write down the points. That way I can see what you've done. That way, if you did read the graph wrong, it could happen. That, you know, it's okay if you start with a different point than I start with, but do your best, obviously, to have the same points from the graph. And then the tail is at the point 1, 3. So in component form, this vector is 5 minus 1 and negative 3 minus 3. So the components are negative 4, 6. So to find the magnitude, we would take the square root of 16 plus 36. You can have a decimal here. This is radical 52, which is 2 radical 13. This, if you can't figure out what quadrant it's in by the picture, remember, move your axes so that the tail is right at 0, 0. Now you can see it's in the 4th quadrant. So we do want an angle between 270 and 360. And so this angle is going to be the tangent, and it is always b over a, so negative 6 over 4. Now when you put that in the calculator, you get negative 56. Of course, we want to add 360 to that, and so that the direction, the angle is 303.90 degrees. I don't know why I don't have 3 decimal places there. I don't have the calculator in front of me, so 3 decimal places is what is, of course, preferred. So for number 7, we don't have to do any of that head versus tail stuff. You do have to know that it's in the 2nd quadrant. So we would have the magnitude being the square root of 3 squared plus 5 squared, which is 25. And so this is radical 34. If you'd rather have a decimal, that's fine. This decimal is 5.8. The other decimal, of course, 7.2. If you'd rather have the decimal, no problem. And then for the angle, we have the tangent of b over a. Make sure you put it in the 4th quadrant. This one gives you negative 59. We're in the 2nd quadrant. So negative 59 plus 180, and you'll have 120.964 degrees. This is resolving the vector into components. This is also going to be on the quiz or the test. So we're going to take 10 times the cosine of 210 and then 10 times the sine of 210. This is not imaginary. There's no I. We're putting it into components. So you should have in the right brackets. There is a comma in between. So 10, the cosine of 210 is negative radical 3 over 2. And then 10 over 1 times the sine of 210, which is also negative. It's negative 1/2. So we would end up with negative 5 radical 3, negative 5. No decimals there due to the fact that 210 is on the unit circle. Then to continue on with our complex numbers. So we were given a complex number. All of this is on the quiz. All of this, all of number 10. So be sure to pay attention to all of that. Make sure you understand the words. Argument is the way we would express angle. Absolute value is the way we express magnitude, and then, of course, the graph. So we're looking for the angle. The graph might actually be helpful first. We're going to have to graph it anyway to figure out what quadrant it's in. So I'm just going to draw the graph first. So we're going to go over 4 on the real axis and then down 3 on the imaginary axis. So this vector, this complex number, is in the fourth quadrant. So we want to put it in fourth quadrant. So the tangent of the angle is -3. Don't use the I, over 4. You get -36 here with the decimal, obviously, and then add the 360. So this angle is 323.1 degrees. Absolute value, well, the square root of 16 plus the 4 squared and 3 squared, that's 25. Oops, so we'll get just a plain old 5. And of course, I already drew the graph. Now this notation is written in vector form, but the vectors are really the complex numbers. So it's not supposed to be confusing. It's supposed to actually make this seem a little bit simpler in terms of actually performing the operation. So we've done this before. Your calculator is also very good at this. So either do this yourself or put it in the calculator. So we have z, which is -3 plus 2i, and then minus w, which is 4 plus I. I'm going to distribute the negative sign and combine like terms. So this is -7 plus I. Please make sure it is in the form A plus BI. There's lots of examples of it around everywhere. So if you forget the order, if you don't have your calculator, something along those lines, just look around and make sure it is A plus BI. To multiply, this is distributive property, or put it in the calculator. If your calculator gives you a data error that you cannot remove, that means your calculator won't do these. If you put this in the calculator, you end up with -14 plus 5i. And then, of course, division. That's all this is. Just set it up and put it in the calculator. Of course, remember to put everything in parentheses. So we have -3 plus 2i. That needs to go in parentheses if you're using the calculator. The denominator also needs to go in parentheses. And then get the answer. This does have a common denominator of 17. It's -10 plus 11i. Remember, the I should go in the numerator. Now, if you don't have the calculator doesn't work here, you multiply the top and the bottom by the conjugate of the bottom, which is 4 minus I. And then, of course, make sure it's simplified all the way. Now, this next section is not something we've really done, sort of on purpose. I will tell you, for those of you who are watching the video, obviously none of you not watching the video, don't give away my secret. This is actually all the bonus questions. I don't know that there are 5 bonus questions, but there are several. There might be 3 or 4. And they all come kind of from this, where you're tying together what we've done with something that maybe in using something we haven't actually used before, like this double radical. So you know what the words mean, you know what the process is, but this has got a whole bunch of radicals in it, so it does seem a little bit weird. So to find the absolute value of this vector, it would be the square root of radical 2 squared plus radical 2 squared. All arithmetic that you can perform pretty easily. Radical 2 squared is 2. 2 plus 2 is 4. And the square root of 4. So the absolute value of that number is just plain old 2. The argument, the angle that this angle lives at, would be the tangent of this angle is negative radical 2 over radical 2. Well, this is just -1. If you throw that in the calculator, you get -45 degrees. So this is 315 degrees. W squared. Kind of weird, but again, not impossible. You know how to do this. We've just not done it with radicals and imaginaries. So radical 2 minus I radical 2 times another radical 2 minus I radical 2. This is not absolute value. This is truly take that number and square it, multiply it by itself. So radical 2 times radical 2. That's a plain 2. Outside, we get a minus I times radical 2 times radical 2. So that's a plain 2. I know it's written weird, but I did that on purpose. Inside, we get another minus. The I is there, and radical 2 times radical 2 is plain 2. Then the last two. These two. Negative times a negative is a positive. I times I is I squared. Radical 2 times radical 2 is a plain old 2. So if we simplify this a little bit better, we have 2. These both match. It's a minus 4i. I squared is really -1, and so we multiply that times 2. This turns into -2. 2 times -2, we get a -4i. Now they would like the angle that number is that we just found. These all kind of build on each other, which is why they're kind of in this order, which is kind of a tip for the extra credit problem if you're interested. I'm going to just graph -4i. I feel like we don't need to mess with this. -4i is just straight down. Right? That's where it is. This is your imaginary axis. Positive is up, negative is down. This angle is either -90 or 270. I'm going to call it 270 degrees. Right? Why make it harder than it is? Let's just make some common sense. Now, the argument out of W third, here's a trick on this. We didn't calculate W to the third, and I don't think that's a good idea. Let's see if we can figure out a pattern. I feel like since they've kind of led us through this progression, that there must be some sort of pattern. The argument of the first one was here, 315 degrees. The argument of the second one, which was W squared, was 45 more degrees in this direction. So we're spinning it down. So I feel like if we keep going and just do the argument for W to the third, it would end up right here. So that is 225 degrees. Again, none of those are actual test questions. Those would be all extra credit. You're welcome. I put them on the form on the review sheet. Not sure why, but I did it, so there it is. Now, to write in a complex form, this means, to write the complex in polar form. Polar form is r theta. R is found by taking the square root of a squared plus b squared. Drop the I, drop the negatives. This is 9 plus 16 underneath here, which is a 5. Then we need the angle. This angle is located, if you graph this, -3, so we're here. Third quadrant. So we're going to have the tangent of our angle is -4 over -3. Make sure you add 180 to that, so you put it in the correct quadrant. It's 233.1. So it's 5 times the cosine of 233.1 plus I sine of 233.1. 3i. Again, it's a plain number. I'm just going to go from the graph straight up. The radius is 3. We're 3 away from the center, or the pole. And the angle is 90. So let's put this together. 3 times the cosine of 90 plus I sine 90. So if you have just a plain polar, just think of the graph. Rather than try to go through all this stuff, it seems silly to add 0 squared. Oh, again, sorry, forgot about that part. There is one question like these on the quiz where you're taking and putting complex into polar. There's one question like this as well. You're welcome, where we're multiplying. So when we multiply, you multiply the coefficients or the radii together, that's a 40. And then, of course, with the angles, you add them. So this is a cosine of 85 plus I sine of 85. Yeah, that's on the quiz. Another question that's on the quiz is this one, number 15. To put this into rectangular form, it feels like distributive property because it is. So we're going to have 6 times the cosine of 150 plus 6 times I sine 150. Now remember, this is a number. This is not in parentheses. There is no comma. When you do the cosine of 150, you get rid of the word and the number. So this is going to be radical 3 over 2, and it's also negative. And then this one is going to be 6. The sign in the second quadrant is 1/2. It's positive. And so we end up with -3 radical 2 plus 3i. Oh, I forgot my I in the problem there. Drawing the complex number on the polar grid, not something we've really done too much. We did points, but we've never really just graphed this. It's exactly like what you think it would be. Use the angle. So basically we're graphing r and theta, but we're just going to connect it. So the radius is 2 and the angle is 210. So that means on our 210 line, which is right here, we're going to go out 2, and you just draw this in like a vector. There's one of these on there. 180 clearly is right there, straight to the left, and we're going to go out 4 rings. 1, 2, 3, 4. This is a vector. The tail is at the pole. The head is at the final concentric circle, whatever your length of your R is. Then the story problems. Now, the story problems are not very complicated, and there are two story problems, and they are both like this. One with some parametric equations, and one with a picture dealing with the angle and the distance. So let's start with this one. So we've got a kayak going across a 200-foot wide river. The river flows at 1.5 feet per second from west to east. She's going to go from the south shore to the north shore, so she's going this direction, and she's going at a speed of 4 feet per second. T is the number of seconds since Sue left the south shore. Assume she starts at 0, 0. Write parametric equations for Sue's path. Parametric equation, remember we define x and y separately, but we use t for both of them. And so this is basically distance equals rate times time. So the x direction, the left to right direction, 1.5 times t, and the south to north, which is also positive, is 4t. They're asking for the component form after she leaves 0, 0, after she's been paddling for 30 seconds. So it's just 1.5 times 30. And 4 times 30, but put this in component form, please. So this is going to be 45, 120. If the current was flowing twice as fast, would it take Sue twice as long to cross the river? So if we think about the magnitude or the length that her vector makes with the current river situation. So her current river situation, if you think about 1 second, I always like to do that. So 1 second would put us at 1.5 and 4. And so here's your A and here's your B. So at 1 second, we would have the square root of 1.5 squared and 4 squared. I can't remember what this number is, but if we take the width of the river and we divide by this number, we get 46.8. That would be her time it would take. If we double the river and call that 3, but her rate stays at 4. So if we think about these components, A and B, so then we would have the square root of 9 plus 16, that's 25, so this is a 5. So then if we take that same river, 200 feet wide, and divide by 5, this works out to be 40 seconds. So when the river goes twice as fast, it only goes from 46.8 to 40. So no, it would not take her twice as long. Why does it take her? It takes her even less time, apparently. Okay. Sorry, that seems weird. I don't know if I did something wrong. Maybe I don't know what that number is at 1.5 squared plus 4 squared, so it seems like it would be smaller if we did. Yeah, it seems like it'd be bigger. Okay, so it took her more time. So for number 18, there's also one question like this. Oh, on part number 17, it's only part A and B on the quiz, not part C. So for 18, to the nearest, a group of people on spring break they sight a shark in the ocean, but they're safely on the beach watching it where it's going. The shark travels 80 degrees north of east. So let's draw this. So 80 degrees north of east. Here's my 80 degrees. Wait, I'm going to get rid of this here. I need a little more space. $80 degrees north of straight east. Right? This is west, this is east. And that is, the length is 12 kilometers. Then, of course, I like to put my little compass back here. And now the shark turns and travels 20 degrees south of east. And this is for 8 kilometers. To the nearest kilometer, how far is the shark from the people when they first started watching it? So the people are here, and this is what we're looking for. We have to put this in component form first. 12 cosine 80 plus 8 cosine of negative 20. And then we would have 12 sine 80 plus, that's an 80, plus 8 sine negative 20. So when we put this in vector form, you end up with 9.601 and 9.081. And to find, of course, the magnitude or the length, the distance that the shark is from where the people are. This is in kilometers, of course, so we have 9.601 squared plus 9.081 squared. I don't know why I mentioned kilometers in case you were worried these people were going to get eaten. And it does say to the nearest kilometers. If we round that, it makes that 13 kilometers. Then to find the angle, of course, it's b over a, so this will be the tangent of our angle, is going to be 9.081 over 9.601. And we're going to leave this as a positive angle because we know that the direction is just a little bit south of east. So we're not really expressing this as an angle from 0, and it works out to be 43 degrees to the nearest degree, 43 degrees, and it is south of east. So that's everything that's on the quiz. So the review sheet seems long. The quiz only has 17 questions on it. There's just a lot of space, and there's a lot of graphs. So there's kind of a lot of pages. There's not really a lot of length to it.